Welcome to Chapter 1, Voting Theory. So I'm looking here at the textbook, and I want to talk to you about this first chapter and give you a brief introduction. So this chapter, Voting Theory, is all about how we as a democratic society make our decisions. We vote for things. We vote for the President of the United States. We vote for our favorite other Congress positions and senator positions. We vote for our Rookie of the Year and NFL MVP and Major League Baseball MVP. We vote for Olympic cities where the Olympics are going to be held in the future. All kinds of voting in our world. And so the question is, how can we do voting as fairly as possible? What is the mathematics behind voting? What is the theory behind voting? Now that might seem like a really silly question at first. I know it would if somebody said that to me. I'd say, there's a whole math chapter on voting? You just add up the votes. It's just adding. What could be harder than that? Or simpler than that? Well, let's take a look at a couple of things in this brief introduction. First off, here's an example of an election. Let's say a vacation club is trying to decide which destination to visit this year. Hawaii, Orlando, Florida, or Anaheim, California. So this is right here. This is your textbook. This free textbook available online. I'm reading right in the beginning of Voting Theory here. And so the vacation club is trying to decide where they should visit. Should they go to Hawaii or Orlando or Anaheim? So they take a vote. Bob votes like this. His first choice is Anaheim, followed by Orlando, followed by Hawaii. Anne wants Anaheim also, but she prefers Hawaii over Orlando. Mary likes Orlando best, followed by Hawaii, followed by Anaheim, etc. So they all place their votes. Now, what we want to do is organize their votes. So for example, if you look at AOH, Bob is the only person who prefers Anaheim first, followed by Orlando, followed by Hawaii. That's why there's one right there. That's representing Bob. Now let's go to the next setup, AHO. How many people? It says 3 here. AHO, AHO, AHO. See how those 3 all go there? In other words, 3 people, their preferences are Anaheim first, followed by Hawaii, followed by Orlando. Let's try another group. How about the next one, OHA? 3 people have that preference, OHA, OHA, OHA. Sure enough, those 3, that's what Mary, Omar, and Dave, they all voted Orlando first. Their first choice is Orlando, second choice is Hawaii, and then Anaheim. So they're listing their preferences, first choice, second choice, third choice. Finally, we have HAO. 3 people said them in that order. Let me try to write that a little bit better. 3. So that would be HAO, HAO, HAO. So those 3 prefer Hawaii first, followed by Anaheim, followed by Orlando. Okay, so everybody has different opinions. So how do we determine the will of the people, right? How do you have a big group of people? How many people we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people. How do we take 10 people? They all vote their preferences. They say what their first choice is, second choice is, third choice is for where the club, the vacation club, is going to go this year. What is the will of the people? We can only book one trip for the whole group. They want to go together. So what's the will of the people? That's what this chapter is all about. How can we use math to help us be as fair as possible in determining the will of a group of people? What are we going to do? Well, One method is the method of plurality. The method of plurality. How does that work? Well, right here. In this method, the choice with the most first preference votes is declared the winner. So in other words, who got the most first place votes? Let's try it out. Come down here. We're going to repeat this same table is repeated right down here. So let's take a look at it. So Anaheim got first place votes by one person and by three people. Anaheim got 4 first place votes, whereas Orlando got 3 and Hawaii got 3 first place votes. That's just first place. We're not thinking about second choice or third choice. So 4 people put Anaheim as their first choice, right? This one person who voted AOH and these 3 people who voted AHO. Who were those 3 people that voted AHO? It's these people. It's Ann, AHO, and Eve, AHO, and Jim, AHO. So those 3 people, and then the one person in the front, that was Bob, I think, right? Bob also had Anaheim first, although he switched the options on the other 2. So these 4 all have Anaheim first. That's their first choice. So maybe the most fair thing to do is just to say Anaheim is the winner. We're going to go to Anaheim as a group. Maybe that is the most fair way to determine the will of the people. That's called the plurality method. So there we go. Is that fair? Is that a good way? Well, let me come down here, and I'm going to ask you 2 questions in the video quiz. So in the video quiz, this is going to be the overview video quiz from chapter 1. Here's the first question I'm going to ask you. Question number 1. It's going to be, which method do we use in the United States presidential elections? And here's your answer. Plurality. That method we just saw. We use the plurality method. Meaning, what? What did it say up here, plurality? In this method, the choice with the most first preference, most first place votes, just like Anaheim, had the most first place votes, right? Isn't that what we do? In the election, nobody even asks us our second favorite and third favorite, do they? When you go to vote for the president, you just vote your favorite. They don't even ask you your second favorite, third favorite, fourth favorite, fifth favorite. Notice, we don't even give them our preferences. We don't even do a whole preference ballot. So that's the method we use. Now, what's the problem with that? Well, let me give you an example. What if we had, let me make a little chart here. What if we had this kind of situation, and we had, let's say, we had first choice, second choice, all the way down to 10. What if we had 10 candidates running for an office? The candidates, the people that are trying to become president, will be A, B, C, D, etc., all the way to J. That's 10. This is a bad-looking D. There we go. 10 candidates. And let's say 100 people like A best, followed by B, on down, and it's kind of went in alphabetical order. And then 99 people like B best, followed by C, D. They also went alphabet, but they put A last. And this is the first place. Here, let me do that a little better. This is first choice, second choice, etc., all the way down to 10th choice. All right. So this is C here, etc. So the question is, what's the will of the people? So in the plurality method, by by plurality, who's going to win this election? Who had more first place votes? A had 100 people. 100 people put A first, and 99 people put B first. So A wins. A got more, just barely, more first place votes than B. A got 100, B got 99. So by the plurality method, A would win. That's how we would do president, right? They wouldn't even ask us. All this stuff down here wouldn't even be known. They wouldn't even ask us our second favorite, third favorite, etc. Wouldn't even know it. So all we would say is, who's our favorite? So say 100 people put A first, 99 people put B, so A wins. Now, here's my question. Is that truly the will of the people? Because that's the job in voting, right? That any voting system is supposed to determine as fairly as possible what the whole group really wants. You know, who do they like best? You might say, well, yeah, A won. Well, hold on. These 100 people like A best. How did these 9, and B only had one less first place vote. I mean, it was really close, right? A got 100, B got 99. Now, how did these 100 people that voted in A, how'd they feel about B? Well, they had B second. So they had A first and then B. Out of 10 candidates, they liked B a lot, just not quite as much as A. How about the 99 people? They had B first and A dead last. So notice these 99 people can't stand A. He's their least favorite candidate. They'd rather have anybody than A. And they prefer B. Whereas the 100 people like A best, but they really like B also. So do you see how everybody pretty much likes B? All 199? 199 people have B first or second, don't they? 99 of them have B first, and 100 have B second. Whereas 99 people, almost half the crowd, have A last. They can't stand A. So wouldn't we say that the people in this situation really like B better than A? Right? A only got one more first place vote than B. Only one more. That's barely. And then the other 99, they can't stand A. So wouldn't it be true to say that these 199 people, this crowd, they really like B better than A? Yeah, A got one more first place vote, barely, 100 over 99. But everybody else likes B. B is first or second by everybody, whereas A, half the crowd can't even stand A. So B is actually preferred. Preferred over A. Wouldn't you say? By the whole crowd, all things considered. So the method of plurality here, which only looks at the first place, would give the election to A. Say, well, that's the will of the people. They've elected A, but that's not really true, is it? That's not fair. If you were candidate B, you'd think, no way. I only got one less first place vote, and everybody likes me best or second best, and half the crowd can't stand A. That method is not fair, right? So the plurality method, where you only look at the first place, that's the plurality method. All you do is look at first place. That's how we elect the President of the United States. We don't even ask the second, third, fourth, fifth, etc. preferences, do we? We only ask, what's your favorite? We don't even ask the others. And so we use the plurality method to elect the President of the United States. And this is a clear situation in which the plurality method's not being fair. It's not really a good mathematical system for determining the will of the people, what the crowd likes best, who the crowd likes best. So, for that reason, in this chapter and in real life, in society, because that's what this math course is all about, is how math is being used in our real world to help us do things better in life. And so in the real world, we've gone on to other methods. So here comes another method. Because plurality is not always fair. It doesn't really tell you that it's not always a fair method for determining the will of the people. That's the job of a voting method, right? To determine what the crowd wants. So because plurality is not always a fair method for determining the will of the people, as we see in this example, they've come up with some other voting methods. So plurality is one method. So these are going to be the methods. Plurality is one of them. Another one is board account. Board account is where you give points. That makes sense, doesn't it? How could we have made this election more fair? Well, we could have given points. And we could have said, when you get a first place, when you get last place, that's only 1 point. Then 2 points, 3 points, etc. All the way up to 8, 9, 10 points when you get first place. So we could give points. The higher you're ranked, the more points you get. And I won't go into any more detail. That whole method is called board account. It's another method for determining the will of a crowd, the will of the people. Just give points. That way all your preferences count. The higher somebody votes for you, the more points you get. The lower, the less points you get. Then just add up all the points and see who has the most points. That's called the board account. There'll be much more detail in the other videos. But let me tell you, that is used in the real world. They use it to determine the Major League Baseball and NBA, National Basketball Association, MVP, the most valuable player, is determined using the board account method. So is the Heisman Trophy winner. Oops. Heisman Trophy winner in college football, that's also decided by board account. So other social situations in life use other voting methods. The board account method is used in a lot of sports. They have the coaches vote and they add up all the points. That's how they determine it. Now, there's board account actually can do some other things that aren't fair in other situations. And so we have a third method called instant runoff voting. It's also called plurality. Plurality with elimination. It goes by two names. You'll read about all that and solve problems involving it. It's a third method, instant runoff voting or plurality with elimination. And that is used when they pick an Olympic city. I don't know if you know, every 4 years they need to pick a new city for the Summer Olympics, and then alternating the other 4 year, every 2 year span off of it, they pick the Olympic city for the Winter Olympics. Anyway, cities love to have the Olympics come to them, and there's a committee, an international committee that votes from several nations. They're the Olympic Committee, and they vote where the Olympics are going to be held in the future. So Tokyo, Atlanta, and Beijing, China, and all the cities in the world that would like to have the Olympics, they prepare a report and they tell what they can do for the athletes and the people visiting. And this Olympic Committee votes using the method called instant runoff voting or plurality with elimination because they believe that's more fair for what they're doing. There's actually a fourth method because that method, too, can do something unfair. Another method called the pairwise comparisons method. And so here we're coming to our second important question. Let me add a new page and tell you about that. Here is your second quiz question. And I'm going to ask you how many voting methods, at least in this chapter. How many voting methods are we going to discuss in this chapter? The answer is 4. 4 voting methods. There they are: plurality, board account, instant runoff voting, and pairwise comparisons. This is also called Copeland's method. These Last two have two names. Copeland's or instant runoff. Copeland's is pairwise, and instant runoff voting is also called plurality with elimination. 4 voting methods. So you're going to learn how to determine elections with 4 different voting methods. And not only that, you're going to learn about what's fair and what's not fair. Let me show you about that real quick. This is an important handout that is provided for you online. Make sure you grab this. This is the Chapter 1 Voting Theory. You'll see it right in the module. It'll say Important Notes. This right here, notice it's got the 4 methods over here on the left: plurality, board account, plurality with elimination, and pairwise comparisons. And it tells you the strengths and the weaknesses of these methods. And up here, we've got 4 fairness criterion. These are 4 ideas about what's fair. In other words, any voting method that is truly fair should follow the majority criterion, should follow the Condorcet, that's a French word there. French guy came up with the Condorcet, or the monotonicity criterion, or the independence of irrelevant alternatives criterion. We have these 4 measures of fairness. And so we're going to take our 4 voting methods and we're going to say, hey, how do they do in these 4 measures of fairness? Because we're trying our best to let math help us determine the most fair way to determine the will of a crowd, the will of a group of people. What do they really want when different people vote different ways? What's the most fair method for determining the will of the people? We've already seen the United States presidential elections does not do the best thing. That should be changed. The plurality method that we use in the United States is not fair. You can see it right here. Here's plurality. What's the weaknesses? Only considers your first choice, and it violates what's called the Condorcet criterion. You'll learn about that in the chapter. So here's board account. Notice it violates, that's the one with the points. You'll learn about how to do that. But it violates 3 of the criterion. The plurality with elimination, also called instant runoff voting, which is the one used by the Olympics. It violates monotonicity and Condorcet. The board account, this is the one used for the Heisman Trophy and baseball and basketball MVPs. And then, but it has problems. And then finally, pairwise comparison, also called Copeland's method. This is the one. It also has a problem. Notice it violates the independence of irrelevant alternatives. Although it satisfies 3 of them, it's pretty strong. It only has 1 violation. So notice they all have 1 violation. So in other words, none of them are perfect. None of these 4 are perfect. You're going to want to use this chart to help you on the exam. You're going to want to put this in your notes. You're allowed to use a full sheet of notes for the exam. Full sheet of notes is with notes on both sides for the exams we take. And so you're going to want to put this chart on your full sheet of notes, print it out, do whatever you want. Anyway, that leads us to this question. If none of these 4 methods are perfect methods, they all violate one of the fairness ideas, which you'll learn more about in the homework, well then, is some other method out there perfect? And the sad answer is no. We're going to end with this. Arrow was a mathematician in the 1970s, Kenneth Arrow, or do I get the, you're right? 1950. Oh, I'm off on that. 1950. It was proven by Kenneth Arrow in 1950, Arrow's impossibility theorem, and that is, it is impossible to have a perfect voting method. Mathematics has actually proven that there is no, and there never could be, not just that we don't have it now, but that it's impossible to have one. There's no way you could design a voting system that'll be perfect. Every voting system must violate at least one of the 4 fairness criterion. So now we know the story. There is never going to be a perfect voting system. So therefore, we have different voting systems used in different places in society. Heisman and MVP have decided they like board account best. Although it has problems, it does the best for them. The Olympic committees have decided they like the instant runoff voting. It works best for them. The United States presidential elections are using plurality, and that's not working that well, so maybe change will come in time with the understanding of the mathematical problems with the plurality method. So there's a quick overview of this chapter. We're learning math that will help us determine the will of a crowd. Voting theory is what this chapter's